When I built my last 2 grain mills, those were intended for crushing grain. I still had yet to build one that could make flour. I additionally became obsessed with the grind your own peanut butter machines at Winco, and when I discovered there was a machine that could grind both flour and peanut butter, I knew it was on. I had to make one. This machine, of course, is the Country Living grain mill, which comes standard with grinding plates for grain, but with an optional accessory can be modified to make peanut butter, using different grinding plates and an auger instead of a spring. Me being me, I had to scrutinize the design of the Country Living mill because I could not get over how far away the grinding action was extended from the bearings. I thought this would be a weak point and the shaft would be likely to bend. Now of course, never having seen one in person is not a good starting point for this criticism, but I happened to come across some large 85mm bearings from the scrap bin at work, which gave me the idea for this massive contraption that looked more like a lathe headstock than a grain mill, where the grinding action is positioned in the opposite direction of the Country Living one. A much more rigid configuration, in theory. So how does it work? Instead of grain coming in the housing and being pushed away from the bearings toward the grinding plates, mine has the grain entering from the outside and fed towards the bearing by the auger. Now this did necessitate some really oversized components to be able to have the entire auger housing assembly straddling the rotating disc. I'm calling them discs, they call them plates. The other main difference in my design is that my discs screw in from the back, eliminating this ugly screw countersink on the grinding face of the fixed plate, but this would later end up coming back to haunt me because tapping holes in this tough stainless steel proved to be a nightmare. So let's get into it. We begin with the frame, which was basically recycled from my first molding press project. It's 2 plates of steel with accurate counterbores milled in the corners to support these posts that screw between them. The new work here was milling and boring the bearing pockets, and also trimming the posts shorter because I didn't need them to be as tall. So yeah, I kind of reinvented the pillow block here, but hey, those bearings were free. Now let's talk about the flywheel. This was sourced from a broken air compressor pump I found on the side of the street, which I disassembled in another video you can go watch. The flywheel originally fit on the compressor's crankshaft with a taper, and since I wasn't interested in or capable of machining an accurate enough taper for the flywheel to run true, I decided to machine a small 1 1/8 inch diameter register and flat face for it to fit onto my new shaft, which was sufficiently big in diameter to form a good mating surface. The problem is the only 2 features on the flywheel that were accurately true to each other were the V-belt groove and the taper, so I couldn't just stick it in a 3-jaw chuck and the thing would be running true. And plus I didn't have a big enough chuck. To get around this, I machined as close of a matching taper onto a short shaft, and pressed the flywheel onto it in the lathe using a piece of pipe between it and the live center. I then took a skim cut on the entire face, since it was still the raw casting surface. This allowed me to then set it up flat on the milling machine table, and bore the register and face the mating surface. I also drilled the mounting screw holes, and then flipped it over and spot faced them so the screws would fit flat instead of on the original cast surface of the slot. Lastly, I drilled and tapped a hole for a handle, which was one that came extra with my lathe when they broke it in shipment and they sent me a whole extra set of components. Next up is the aforementioned shaft that goes inside those big bearings, which is more like a tube with a cap welded on the end of it. The cap was actually from a fixture for another project that I was no longer using and happened to be the right size for this. I rough turned the flywheel register prior to welding the cap on to take advantage of a more rigid setup. Then after welding, I chucked on the rough pipe diameter, faced the end of the cap and bored a 60-degree taper for the live center. Then chucking on the inner diameter, I held it with the center and turned the entire outer diameter, and finished the face and the register. Then, not shown is me turning it around, chucking on the outside to machine the inner diameter of the opposite end where the rotating disc will fit inside. And lastly, drilling and tapping the mounting holes for the flywheel, and drilling and counterboring the screw holes for the rotating disc. As mentioned before, the discs were made from some tough stainless. The fixed and rotating discs were nearly identical. The fixed one just had a through hole in the middle, where the rotating one had a counterbore for the auger and 2 screw holes to secure it. The fixed disc later also got 4 1/8 holes for roll pins to align it with the auger housing. Here I'm turning the diameter that fits inside the shaft, and I decided to use the same diameter on both discs for convenience. I set them up in the tube to turn the other end true before boring the holes in the middle. Here are the mounting holes for the auger on the rotating disc, and the mounting holes for the disc itself, which again I used the same hole pattern on both discs. These were the ones that were difficult to tap. I used a 5/16 24 thread, and managed to get through all 8 holes with only breaking 1 tap. To remove the broken tap, I first tried welding a handle on it to unscrew it, which didn't work. so I resorted to plunging it out with a small carbide end mill, cleaning it out and retapping it, and by the end of all this, the tap I bought for this was totally toast. So yeah, I've learned why countersunk screws through the face is the better option, even though it looks ugly and gets grain stuck inside where you put the hex wrench. For the serrations on the disc, I was originally going to cut them with this dovetail cutter, but realizing I didn't have a 1-inch holder for it, resorted to tilting the head on the milling machine and cutting them with a standard 3/8 end mill instead, though this meant the geometry wouldn't be the nice sawtooth profile I originally wanted, which might come into play later. But now let's talk about the auger. This was the only component I knew that I didn't have the knowledge or ability to machine in the beginning, so I considered just buying a meat grinder at a thrift store and pulling one out of there. But then I learned how to use the 4-axis milling setup at the makerspace, which made machining this component possible. I first tested it on wood, then aluminum, and finally made the real thing out of stainless. It was such a beautiful milestone for me, and I'm so proud of it. One end of it got turned down to 1 inch to fit inside the rotating disc, along with getting the corresponding mounting holes tapped, and the other end was turned down to fit into a bearing in the back of the auger housing. Before we get to said housing, we have to talk about what I'm calling the plates, which are 2 flat pieces of stainless forming the gap that the grain falls through. The plates also dictate the size of the gap between the grinding discs by 4 spacers between them. I started by facing them both flat in the lathe. The bearing plate got a hole bored in the middle to clear, just slightly, the rotating disc, and then the housing plate had a hole bored to fit the fixed disc inside. Both plates had the same hole pattern drilled to align and mount them to the frame. 4 holes for stripper bolts for alignment, and 4 tapped holes for socket head screws. Since I'm notorious for not making blueprints of stuff that I build, I stamped the coordinates of the holes onto the frame for future reference. The housing plate also later got the 4 1/8-inch roll pin holes to align it with the housing and the fixed disc. Now for the auger housing, which was by far the most unnecessarily cool looking component. Starting with a block of stainless, I squared the sides in the milling machine and drilled holes for the corners of the final outer profile. I set it up in a 4-jaw chuck on the lathe to drill and bore the clearance hole for the auger, as well as a shallow counterbore for the back bearing retainer, which supports the free end of the auger. Then, after drilling some more holes, I began milling away the corners to make the outer X-shaped profile. At the end of the day, this was really an unnecessary amount of effort to reduce the weight of this, then cleaning up more material, then tapping holes for the bearing retainer that I almost didn't have room for, and then milling the opening in the top for the grain to enter, and tapping holes in the side for an eventual hopper. And then the part that brings it all together, milling a shallow register to grab onto the small diameter of the fixed disc that had barely enough sticking through the housing plate for this to work. And then those 4 roll pin holes again. And for the bearing retainer, it was just a piece of round stock with a borer for the bearing, an internal snap ring groove, and some half counterbores for screwing it onto the housing. And look at that, we're ready to put it together. First, sticking the shaft onto the bearings. Then the rotating disc and auger assembly goes into the shaft, which is held in with 4 6-inch 5/16 24 socket head screws. I took advantage of the old hex boss that was on the fixture I made the shaft cap from to tighten them. Next, the flywheel. I made this little spacer to take up the gap between the flywheel and the bearing so the shaft can't slide back and forth. Here are the 4 screws that attach the flywheel onto the shaft, and there was a bonus 1/2-inch screw from the tapped hole in the middle of that old fixture. Here we can see some smooth rotating action. Now for the bearing plate. I'm temporarily aligning it with the 4 stripper bolts, which act as dowel pins. I later turned the heads off of them to make assembly easier. Before anything else, I decided to put the bearing retainer into the auger housing, which has a slight press fit. Then, aligning the auger housing plate to the fixed disc with those 1/8-inch roll pins. This is an anti-rotation feature. Then fitting the auger housing onto the same 4 roll pins, and hammering it all together. The pins engage in all 3 components, and the housing register engages with the fixed disc. These 3 pieces are held together with some more 5/16 24 screws. For those of you tuning into my other channel, these were the screws I bought in my Ontario Bike Quest video. I would have much preferred to have socket heads, since the hex heads almost blocked me from putting the bearing retainer screws in. Now sliding the entire assembly onto the grain mill, aligning it with the stripper bolts, then putting the spacers between the 2 plates, and tightening them with the mounting screws. Then the auger bearing fits in, along with a snap ring to prevent it from falling out. It's so smooth. So learning the lesson from my last grain mill, I decided to make it not adjustable spacing with like an easy method of adjusting it. There's this spacing gap right there. I think it's about 10 thousandths. The way to adjust the spacing is unscrew the screws with the spacers under it and just put shim stock in it. I didn't want to do the complicated method of this huge threaded mechanism to scoot the thing in and out. I figured I'd be better safe making it not adjustable. Oh my gosh, this thing's going to be annoying to clean, having to unscrew all the screws. But let's try it out. I want to make a pancake. Let's grind some wheat. Granted, I don't have the hopper done yet, so it's just testing mode. It would appear the grinding is not that effective right now. Or the spacing is not good enough, or some other excuse. I also tried it with peanuts off camera, but it didn't work. I also tried cutting the disc grooves deeper with an angle grinder, experimenting with all different size spacing gaps, and it still didn't work. So why did it not work? It's probably due to the disc geometry. As you can see, the actual ones have a lot more serrations, different profiles. I was trying to accomplish both peanut butter and grain grinding with the same auger and discs, which the country living doesn't even do. My auger was also problematic. I originally thought it was maybe too small in diameter, and also the helix angle is a lot more aggressive. But the more I look at it, I think that on the peanut butter one, the helix action ends way ahead of the grinding action, where mine goes all the way up to the discs. And for the grain auger, which is just a spring, it doesn't even take up the entire diameter of the passage through the housing. It's more gently moving the grain instead of pushing it. I'm sure with a bit of more work, better disc grinding expertise, or just buying some pre-made, I could have got this thing to function. But this was another one of those projects that I kind of lost interest in halfway through, so I decided I'm going to turn it into a lathe. That's right, I'm building a lathe from scrap parts, so be on the lookout for that project in the future. So until then, it looks like Winco will still be getting my peanut butter business. But hey, at least I got the best doorstop ever out of it.